Okay, today I'm going to talk a little bit about planning an experiment related to experimental design. And there's a saying, in carpentry, measure twice, cut once. And really, it's a truism. It's about, kind of planning your next move and being efficient with your resources. And it's no less true with experimental design. You really want to plan what you're going to do before you start collecting any data. If you have good planning up front, you're more likely to succeed. So just to help you get started, I've created this simple worksheet in Excel. There's lots of worksheets out there, how to plan experiments and so forth. So this is just super simple one, just one of many, and you can feel free to use it or not. But just to get started, we want to always try to collect information about who was prepared by, and what date. So down the road we can go back to this person and say, hey, do you have any more information on this experiment or whatever. Statement of the problem, this is really critical. This is really about what you're trying to do. So maybe I'm doing an experiment here on some kind of plant growth and I want to optimize plant height. So that's my statement of the problem. And then what is the objective of the experiment? So the objective is to determine, for example, if soil or fertilizer have an impact on plant height and to what degree. Okay, so we have a statement and then we really have the objective, which is a little bit more detail. And then always have something about resources. What do we need? We need maybe potting soils, we need 4 containers, maybe a sunny patio or something like that. So it's always critical to have a listing of what you actually need. And then we actually have the experiment itself. So an experiment is about changing certain factors in some process and seeing how it is on some response or output. So you have this process box, or I call it a puzzle box, which is plant growth, and we want to alter some factors going into it. Okay, and there will be things that we can control, things we can't control, and then also what we're going to measure. So for example, we have 2 factors we've selected. One might be soil pH, one might be fertilizer, and the experimental levels. This is set up for a 2-level type of design. One might be at a low level of 6.7, one at a high of 7.5, and maybe fertilizer is a quantity, maybe 1 pound versus 2 pounds, something like that. So I would, form what's called a 2-factor, 2-level experiment. And then that goes into the process or the puzzle box. And then things that I can control and keep constant, I can actually list here. So maybe I can control what kind of soil I'm going to use, the irrigation, the weeds, if there's pests or whatever. Those are things that I can kind of manage. But there will be things that I can't manage too. Maybe the rain, the clouds, temperature, and general weather type phenomena. So these I can't control, and they'll actually form part of that noise component in the experiment. And then what I will measure. So this is also critical. It's like this experiment, what's my final outcome? And you can actually measure more than one thing, but just for sake of simplicity, we're just measuring one item here. And then I also like to have a little list of questions, just to remind myself what else I need to look for. So we have, have I formulated the proper research question? It seems like we have. Have I chosen the correct design type? And do I know how to analyze the data? So, we have a 2-factor, 2-level design, and I have some design templates over here. Let's actually look at those now. So these are full factorial designs, which means you run everything. So here we have a 2-factor test, 2 levels, and if you run everything, you have 4 combinations. And I've also included a random order generator here. So when you run an experiment, you always want to randomize your runs. Okay, there's certain properties of randomization that really help out in the analysis and the validity of your experiment. I've also included 3-factor experiments. So here you have factor A, B, and C, each at 2 levels. And if you calculate it out, that's 8 runs. And then I've actually included a 4-factor full factorial. So here's 4 factors, A, B, C, and D. At 2 levels, that'll generate 16 runs. And I've left a column here just to list what the factor levels are. So, it might be like low pH, high pH, something like that. So you know what these levels are and what the factors are. And then I've left some room for a response here as well. So left room for about 5, and you can actually determine what your true sample size is, but 5 might be a good start, just to get going. So let's go back to our experiment planning sheet. So, chosen a design type. And again, those were full factorial designs. They're not fractionated, so, that's a different topic, but we can start there. Are my test levels sufficiently far apart? So is this, level separation far enough apart, or is it too close? Do I have the resources needed to perform the experiment? So do I have the right, pottery, the right soil, and the rest of it? And this is a good one too. This is really important. Have I communicated with everyone I need for this experiment and obtain their input? So you can sit, your desk and develop a design, for an experiment and think, wow, this is perfect. This is everything I need to know, all the variables. But it's always a good idea to get like a second set of eyes on it, just kind of get a check, like, does it make sense? Because somebody might come back and say, this, you don't really need to test this. This isn't a factor. We've done it in the past, or whatever. Or for large experiments, you probably actually want to facilitate some kind of group to really, nail down the factors and the levels and everything else. So just always a good idea to get input on your designs and let everyone know what's going on. So when you're running a design, people know to, basically either help you out or leave you alone, so they're not messing up something that they don't know what's going on. And the last one's really important, is everything in good working order for the experiment. So, if I'm doing this plant height experiment and I'm using, broken pottery and, it's not holding water and the soil is leaking out, that's going to really influence my result. So, if you're working with machinery, you want to make sure the machinery is in good working order, because you really want to understand, the effect of your factors and the magnitude. If you have a lot of variability, because things are broken, it's going to mask that analysis. Okay. Anyway, again, this is something you can use. You don't have to use it, but just to get started. And that's it for now, and happy experimenting.